Hello students, let us start with the third lecture, autoionization of water. Now, pure water, it ionizes to a very small extent. So as the word itself suggests that autoionization of water, when you take two molecules or rather 2 moles of water, they will react together. Double arrow I put here, so it ionizes to a very small extent. So it ionizes to very small extent. Remember this, small extent. Okay, so this will give you the product as H3O plus. As I already explained you that in some cases this water it acts as a base, and in some it acts as an acid also. So here it is a formation of an protonium ion and OH minus ions also. Now at equilibrium constant, that is K, you can write for this reaction as concentration of this product ions formed on the product side divided by H2O. Here there are 2 moles, so I'll write here 2. This to the power 2, concentration of these 2. So this is your equation number 1. Now if you rearrange this equation, K into concentration of water molecule to the whole square, it will be equal to, I'm just rearranging the equation, nothing else. Concentration of protonium ion and concentration of OH minus ion. This will be your equation number 2. Now majority of these water molecules are undissociated. As I told earlier, it ionizes to a very small extent. So majority of them will remain undissociated. So the concentration of water can be treated as constant. So for this, if you consider concentration of water molecule as a constant, so you can write for this concentration of water molecule as K dash, and if you substitute this, substituting in equation number 2. So you can write instead of this H2O, concentration of H2O raised to 2, K into K dash. This is your K into this K dash. Instead of this, you can write K dash. Okay. And this will be equal to concentration of protonium ion into concentration of OH minus ion. Now what is this K into K dash? This K into K dash, this is known as, right here, K into K dash, it is equal to Kw. So what denoted by Kw, this is what we call as the ionic product of water. This is called as ionic product of water. So K into K dash, this is equal to concentration of protonium ion into concentration of OH minus ion. So I can write in terms of Kw the same thing, H3O, concentration of protonium ion into concentration of OH minus ion. Now, whatever I wrote here, this in this equation, we can write in wordings also. So this Kw, as I told, Kw is equal to K into K dash, isn't it? Now K dash is equal to concentration that is taken as K dash equals to concentration of water molecule. Supposing that or assuming that it dissociates to a very small extent, so it is taken as a constant one. Okay. Now Kw equal to K into K dash. This is nothing but the ionic product of water. This is what we call as the ionic product of water. Okay, so this is ionic product of water. Now this product of, right here, the product of molar concentration. Remember, mole concentration it expresses moles per liter. That is a molar concentration of H3O plus protonium ion and OH minus ion. OH minus ions at equilibrium. At equilibrium. in pure water, at given temperature. So temperature is important here. At given temperature, it is called as an ionic product of water. It is nothing but the ionic product of water. Means in simple way, the product of ions of the water form after dissociating, which is denoted by Kw. Now, this at equilibrium at the given temperature. So at equilibrium, measurable quantities, they do not change, like pressure, concentration, density, they do not change at equilibrium. Taking into account, we have used here the word at given temperature. So at 298 Kelvin, at 298 Kelvin, this concentration of protonium ion, it is found to be 1 into 10 raised to minus 7 molar. Concentration of OH minus ion, it is found to be 1 into 10 raised to minus 7 molar, means moles per dm cube. So Kw, you can write 1 into 10 raised to minus 7 into 1 into 10 raised to minus 7, isn't it? So it is found to be Kw equals to 1 into 10 raised to minus 40. So Kw equal to 1 into 10 raised to minus 14. So to just make this 10 raised to minus 14 as a positive value, we can put it into is convert it into by using the log table. So Kw, as you all know, Kw equals to concentration of H3O plus concentration of OH minus. It is equal to 1 into 10 raised to minus 1 into 10 raised to minus 14. Okay, so 1 into 10 raised to minus 14. Now, if you apply the log table for this, I'll be writing here only for your convenience so that everything should be on the one slide. So log of this H3O plus log of OH minus ions equals to 1 into 10 raised to minus 14. Now, you can write this as log of H3O plus log of concentration of OH minus ion equals to minus 14. We are just putting this raised to the power into this way. Now, if you change this minus sign, I can write here minus log of H3O plus here again you have to minus, put the minus sign for this quantity also for log of OH minus. So minus log of concentration of OH minus ion equals to 14. So I want to make this minus 14 as a plus 14. So that is why I made these changes. So pH equals to negative log of hydrogen ion concentration and POH equal to negative log of OH minus ion concentration, isn't it? And pH plus POH equals to 14. So for this neutral solution, I'll go to the next slide. For neutral solution, we know this all thing. For this neutral solution, for neutral solution, concentration of H3O plus protonium ion equals to concentration of OH minus ion equals to 1 into 10 raised to minus 7 molar. So in terms of pH, this will be negative log of H plus ion concentration. So equals to negative log of 1 into 10 raised to minus 7, which is equal to 7. So when pH equals to 7, solution is found to be neutral. Now for acidic solution, there is excess of H3O plus. So here excess of protonium ion, concentration of protonium ion is more here. So concentration of H3O plus is greater than OH minus ion. Okay, it means that concentration of H3O plus is greater than 1 into 10 raised to minus 7 molar. It means that obviously this pH for this will be less than 7. Means if the pH is less than 7, the solution is found to be acidic. For basic solution, what are the conditions for this? Concentration of H3O plus protonium ion, it is less than concentration of OH minus ion, isn't it? Or concentration of protonium ion, it will be less than 1 into 10 raised to minus 7. So obviously the pH of this solution will be greater than 7. So means if pH is greater than 7, the solution is basic in nature. So you can find out from this, starting with the autoionization of water, you can reach up to this condition which is already known to us. Thank you.